So this says when glucose 1-phosphate is incubated at 25 degrees Celsius with the enzyme phosphoglucomutase, the following reaction takes place. Glucose 1-phosphate is converted to glucose 6-phosphate. Okay, the delta G for this reaction is negative 7.54 kilojoules per mole. So it is spontaneous as written. The question they're asking is, if the initial concentration of the glucose 1-phosphate is 0.15 molar, calculate the concentrations of each species when the reaction has come to equilibrium. Okay? So we're given our delta G, we're given our initial concentration of glucose 1-phosphate. We want to find the equilibrium concentrations. Okay, so let's see what we can do here. So this is essentially an equilibrium problem, and as such, we're going to end up making something called an ice chart, if you remember from general chemistry. So the plan for this particular problem, let me do it in blue. So the plan is, we have the delta G. So they give us the delta G. From the delta G, we're going to find the KEQ, and then after that, we're going to do an ice chart. And ice just means initial change equilibrium, one of those charts that we used to do in general chemistry to track where things start, where they end up, and then do the calculation based on the KEQ. So let's go ahead and do that. So we start with our equation, which is, of course, delta G. I'm not going to go ahead and keep writing the superscripts over and over and over again. So you know that we do all of these calculations under the transformed biochemical standard. So I'm just going to write delta G equals minus RT ln KEQ. So when I rearrange, KEQ equals e to the minus delta G over RT. So when I go ahead and put these values in, KEQ equals e to the minus. Let's go ahead and do. So we said that the delta G was negative 7.54 kilojoules per mole. So negative 7.540, that's kilojoules per mole, over RT, which is 8.315. And we have 298 because we're running this at under standard conditions, 25 degrees Celsius. Okay, what you end up with is e to the 3.043, and you get 20.97. So our KEQ is 20.97. Now that we know what the KEQ is, now we'll do the equilibrium part. Okay, let's go ahead and write our reaction. So glucose 1-phosphate is going to reach some sort of an equilibrium with glucose 6-phosphate. We're going to have an initial concentration, we're going to have the change that takes place, and then we're going to have an equilibrium concentration. This is what we're concerned with ultimately. Well, they said we started off with 0.15 molar glucose 1-phosphate, and we have none of this. So that's our initial concentration. Well, we know the reaction is going to move forward. There's none of this, so it's going to move forward. That means glucose 1-phosphate is going to deplete. It's going to deplete by a certain amount X. Well, the amount of depletion, this is a 1-to-1 ratio, is going to be exactly the amount of glucose 6-phosphate that shows up. So this is going to be positive X. That's the change that takes place. The equilibrium is the initial plus the change that took place. So 0.15 minus X and X. These are the values that I need. And let me go ahead and do the calculation on the next page. So I have KEQ equals X over 0.15 minus X. Products over reactants at equilibrium. Well, this happens to equal 20.97. I know what the equilibrium constant is. I go ahead and solve this equation. X equals 20.97 times 0.15 minus X. I'll go ahead and put 3 dots. You guys can go ahead and do the algebra. What you end up with is X equals 0.1432 molar. That's going to equal the equilibrium concentration of the glucose 6-phosphate. Now, the equilibrium concentration of the glucose 1-phosphate, if you go back, it said it's 0.15 minus X. So when we do that, we get 0.0068 molar equals the concentration of the glucose 1 phosphate. So there you go. That's our final answer. We started with a delta G, we converted to KEQ, we just did an equilibrium problem, and this confirms the fact that most of the glucose 1-phosphate has been converted to glucose 6-phosphate. There's virtually no glucose 1-phosphate left over. Okay, that's it. Thank you for joining us here at Educator.com. We'll see you next time.